welcome to the latest edition of Silicon Grapevine. Today, I have a very special guest, Luc van den Hove, who's the president and CEO of imec. Luc, hello.
Hello, Ian.
Luc, I think you have had a landmark year. We're recording this in 2024, and it's you've celebrated 40 years of imec. For our viewers, just tell us a little bit about this landmark, but also imec's key sort of role in the industry, which is quite a key role actually.
Well, yeah, indeed, this year we celebrated our 40th anniversary. So we were created in 1984. And at that time, actually, I was finishing my PhD student at the university, and we had a pretty strong team at the university doing research on what we called at that time microelectronics.
Yes.
And so it became clear that the cost of doing this research, if we want to be leading, was pretty high, and so it was hard for kind of keep on doing that just at the university. And that was a moment when imec was spun off from the university in an
Yes.
independent research center, and we were quite successful in convincing our government at that moment to kind of invest in imec. And since then, we have been growing year after year, very steady growth over those 40 years. And gradually, we started to realize that if we wanted to be leading in what we're doing, we had to work with the industry, with the leaders in the industry. And so, step by step, we grew our partnerships of industry collaborations. We realized that we had to go international, work with the leaders, and we started to work with many of the big companies. And this is how imec step by step grew to what it is today. So we started at that moment in 84 with a team of 70 people, spun off from university. By now, we have an organization that grew to more than 5,500 people. People coming from all over the world, a very multidisciplinary, multicultural team, and working in driving the roadmap on semiconductors, basically.
I think what you explained there doesn't give it full justice, because I think what imec's role with like a lot of the research and technology organizations is in sort of defining, yeah, it's sort of leading edge technologies, or actually researching and then trying to figure out implementation with your partners, isn't it?
Yeah, sure. So I think over the years, grew, and by now we kind of bring together the entire ecosystem, representing all the layers of the value chain. On the one
Mm.
hand, we work very closely together with many universities, more than 100 universities. This is very important because it kind of fills our innovation funnel.
Mm.
The goal is basically to bridge this gap from lab to fab, to de-risk disruptive ideas and to prepare the manufacturing technology typically 5 to 10 years ahead of the industrial needs. And we do that by working together in the entire ecosystem. And this has become, I think, quite relevant, important, because the cost of R&D, but also the risks of R&D are becoming so big that a
Mm.
single industry company cannot drive this roadmap, and we have to make sure that we align the entire ecosystem. And in this way, we're now working with all the major semiconductor companies. All the leading ones are kind of what we call core partners at imec, and we're the only place where they're all coming together in the world.
Mm.
We're doing all their advanced R&D, but we also have been growing our partnerships with all of the leading fabless companies, but also
Right.
all the material companies, all the equipment suppliers, and the role of imec has been to basically de-risk the innovation roadmap, make
Mm.
sure that we align the entire ecosystem around a common roadmap, and kind of develop the co-develop the technology roadmap together with the end users and the entire ecosystem, as I mentioned. But typically, three, four nodes ahead of manufacturing. And so a lot of what
Yes.
we do is what we call in the pre-competitive space, and that allows us to bring together the entire ecosystem.
That's right, and I think one of the things also imec represents is that strength of the European research and innovation talent. Isn't that right?
Sure. So we are, of course, we're positioned in Europe. This is where we have our headquarters, but we really have grown into a global organization. We work with
Mm.
all the major companies in Europe, obviously, but also we're the primary external research partner for all the companies in the US, but also in Asia, in Taiwan, Korea, um, Japan. We are truly global. And uh, and gradually, I mean, the focus really is on driving core semiconductor technology to the
Correct.
limits, enabling the roadmap. But also more and more, we see that this roadmap has evolved from like a common roadmap for the entire industry, which we all know as Moore's law, basically.
Yes.
But
Mm.
more and more, we see that this roadmap needs to be gets sort of diversification needs to be tuned to its specific applications. And so more and more, we have been growing also upwards in the value chain, focusing more and more on where we use chip technology, which applications,
Yes.
and have this application input, system input in our roadmaps. And we refer to it as system technology co-optimization, basically. And that has
That's
allowed
right.
us
Yeah.
to have to kind of diversify also into new applications like of course the automotive industry now is a very strongly growing market, but also like healthcare industry.
Yeah. Yeah. And I think one of those examples is, for example, the chiplet, automotive chiplet alliance that I think you led, which was an
Yes.
announcement earlier this year.
Yes, because I think it's a very good example of the fact that, I mean, the roadmap is not just a roadmap anymore that is kind of purely lithography driven 2D scaling roadmap, but we will enable more slow basically through a multitude of
Yeah.
technologies and heterogeneous integration, which allows for extremely effective high bandwidth connectivity between multiple chiplets, allows one to big these to build these huge systems that start to operate more as if basically everything was integrated on a single chip. And this allows one to make these big compute platforms. So it's not only to the scaling, which we're convinced is still a very important factor, will kind of be a very essential element to enable Moore's law for the next 10 to 20 years. But it will be complemented also by other technologies such as 3D heterogeneous integration, 3D stacking, 2.5D integration. So those all come together and will be
Okay.
optimized for specific applications like solutions for automotive may be different from solutions for high performance computing or for AI. And so that's why this notion of system technology co-optimization becomes so important.
Right. Yeah. And I think at your flagship events, which is the ITF, I think you hold that in various regions around the world. You've been
Mhm.
talking about that at least for 2 or 3 years, from what I
Yeah,
remember from attending them.
absolutely.
Yeah.
Yes. Mhm.
Uh, Tell us, let's go into a little bit about how you actually sort of came into electronics. It's always a curiosity for people. Sort of, what was the thing that inspired you? Tell us a little bit about your early days.
Well, I would say when I was studying, in fact, initially my plan was not at all to go into electronics. I
Right.
always was dreaming of becoming like an architect because I'm very passionate about architecture, about design, and so this boundary between art and engineering, I think, has always fascinated me. But it's only during my last years, when I was 17, 18 years, that I suddenly got very fascinated also about electronics. It was a time in the early 80s when the first PC came around, the first Apple
Right.
computer, and then I suddenly started to be fascinated about the electronics, and I started to study electronics, and that's how I came into it.
Oh, so I mean, it wasn't a family thing, or it wasn't like a somebody in the family was an engineer, and you're fascinated by that.
Mm,
No,
Not
that's
at all. Not at all.
oh, that's
It was mostly
and
through friends, and by talking with friends that I came to the conclusion. Ah,
and then so then you sort of went to study electronic engineering, is that right? And then how um, you told us about the sort of formation of imec, but how did you get involved in that in the beginning?
Well, I studied electrical engineering, and then I started working on my PhD. And it was at the moment when I was kind of in the second phase of my PhD that this initiative was taken to create the IMEX, spin it off from the university. I mean, we called it Super Lab at that moment. In
Mm,
fact,
mm,
some of our lead professors at the university, they all had spent some time in Silicon Valley, either at Stanford or Berkeley, then came back, and they wanted to create kind of a high tech environment here. And we quickly realized that in order to do that, and in order to really be leading in this domain, we had to invest more. And so we convinced our government to invest in IMEC as an independent research lab, and that's how it all got started.
So is that, I mean, quite often when companies or organizations start, you're sitting around thinking, how do we make this happen? Was there
Mhm.
like a little sort of team that was sitting, I don't know, in a bar in Belgium or somewhere like that, and just saying, okay, well, yeah, we need to do this.
Yeah, it was basically, I mean, it was a relatively small team, and I have to say at that moment we really were not dreaming about setting up an organization of 5,000 to 6,000 people. I mean, the first building that we designed was aiming at 350 people, and we felt that if
Mm,
we can set up an R&D organization of that size, that would already be fantastic. But yeah, history has
yeah.
learned us that okay, we really had to build up the critical mass, and so we grew year after year, and that's how we are now at 6,000. But at that moment, nobody would have expected that we would grow into an organization. Yes,
And you became CEO, I think a little bit later. I think you became CEO in
but
2009.
yeah,
Uh,
15 years. Yeah.
okay. So
Yes. So, Roger Verhofstadt was the first CEO. He started for 15 years, and Gilbert de Klerk 10 years, and now I'm 15 years CEO.
And so you've basically got two sort of little phases in IMEC. One was like the building, and then the second part is leading. Um, I would sort of ask you, what were some moments in the building phase that you said this is something really important?
Oh, it grew gradually. So, I mean, I would say the first 10 years, we started to work on certain topics. We started to go to conferences like IDM and started to
Mm,
publish. So the first 10 years were kind of the starting phase. We grew from basically an academic organization. That's how we started, with a very strong focus on technical excellence. And that is still a very important part of our culture. But we realized that being positioned in this very small country, Belgium, that if we wanted to be leading, we had to start working with the big companies, with the leaders in this
mm,
industry. So we started building up relationships with companies like TI, Intel, and later
mm,
Samsung, and TSMC. And so that's how we started to, in I would say, in second phase. So after 10 years, we started to grow these international partnerships based on the track record of publications, and so that we had built up in the first 10 years. So the second
mm,
phase was basically this phase of internationalization, building up commitment from many of the leading companies. And so then, by I think it was around the early 2000s that we realized that if we wanted to remain leading, we had to transition from the 200 millimeter fab to a 300 millimeter fab. And the trigger point was basically we already had started to work very closely together with companies like ASML. It was right at the moment when kind of the next lithography technology was kind of being explored, EUV lithography,
yes.
and now ASML at that moment was starting to build the first we called it alpha demo tool, but they were building it only on 300 millimeter wafers, and we had a 200 millimeter fab. So we had to transition if we wanted to stay leading in this lithography domain, we had to build up a 300 millimeters facility, and that was a huge step. So
Mm.
we had to finance that new fab, and so we started. It was a pretty bold decision just to start building the facility. We had some government funding to help us, but we really needed to have strong industry commitment. But just by starting it and taking that
Mm.
decision, we kind of created the momentum in the industry to start joining more and more of our programs. And that's when we started, we called it our core CMOS program, which was kind of a collection of programs like on lithography, on new devices, on interconnects, on cleaning technology. And so we bundled that in our core program, and that's how many of the big companies joined our programs as full core partners. And Intel was the first, then Samsung,
Yeah.
then also of the Europeans, TSMC, and that's how kind of this domino effect started to roll, and then all the suppliers came on board, and then in the later phase, the fabless company. So these were some of the major points in our growth curve, and then I would say the last 10 years is when we started to expand more on the application side.
Right.
Uh,
Yeah.
but there were every 10 years there was an important phase in our history.
Oh, okay. No, I mean, what impressed me, I think, probably about 2 years ago when I visited during ITF, yeah, just the latest
Mhm.
ASML and the scale. I don't think people realize the scale of those machines, the EUV machines. And yeah, just walking this whole corridor down to look at all the different aspects of the machine is just amazing. And I think that's kind of where you have a very strong relationship with ASML as well, don't you?
Or absolutely. No, I mean, ASML has been extremely important in our history. I mean, we started to work with ASML. It just happened to be that ASML was created in the same year as imec in '84, and we kind of
Right.
grew together.
Yeah.
And from the beginning, we've been installing first of a kind tools from ASML in our fab, and ASML got a lot of exposure through that partnership. So ASML focusing on the hardware, we focusing on the process, and this has created, as I said, a lot of exposure for ASML. But ASML also has been extremely uh, important in our growth. So this has been truly a win-win relationship, which it is still at this moment.
It's like a coexistence in a parallel path, so it's quite,
Yes,
interesting,
yes,
that
exactly.
you've done
In the
that.
meantime, of course, these technologies have become so expensive that it's very hard for many of the companies to just develop all that on their own, and that's how imec has kind of is bringing together the entire ecosystem, making sure also that the ecosystem is synchronized around
Yeah,
these
yeah,
roadmaps. Because I mean, the resist materials have to develop the materials. The mask makers have to have the mask ready. Reticles need to be ready. So everything needs to be synchronized, and that's to a large extent the role imec plays in the
yeah.
lithography domain, but also in the many other domains.
Got it, got it. Um, what are the other things, in terms of things that have inspired you in your journey? I know you're in a leadership position, but I'm sure there are things that also trigger thoughts in your mind and think, well, this is something that, yeah, we need to be doing, or whether it's career or whether it's personal.
Oh, well, of course, an evolution like this is a result of many triggers. So there's not like
Yes.
one big trigger. Of course, I've been very close to the ASML partnership, which we were just discussing, and
Yes.
in fact, I started my career in lithography, so that's how we
Mm.
built that relationship. I was certainly very much inspired also by the culture and the leadership at ASML. I mean,
Mm.
it's uh, not a coincidence that ASML has been so successful. Is because of their very strong leadership and also the ecosystem that they have developed around ASML. And so I was certainly inspired by the leadership in that company. But of course, there are many other triggers that inspire me. I think, I mean, of course, the many people that we attract to IMEC, the passion that there is in the organization, also the fact that that now with our technology, with our semiconductor technology, that we can enable so much innovation into so many other fields. I think that's
Mm.
also creating an enormous passion among our researchers. In the fact that that the phenomenal evolution that we have seen in communication, in computing, but the fact that we can now apply some of these technologies also like to the healthcare domain and
Mm.
tackle some of major illnesses such as cancer, I mean, or at least contribute to help solving those.
Yeah. Yeah.
Uh, and those are things that are extremely motivating and that create a lot of passion among many of our people, and certainly motivate myself a lot.
And I mean, you talked about that passion. How do you maintain that motivation and passion amongst the teams at IMEC? It must be
Well,
quite a
I
challenge with so many things going on there.
Yeah, but I think that's exactly what is creating that enormous enthusiasm in the teams is the fact that our technology really has such a strong impact to society
Yeah.
and will have an even
Yeah.
more impact, a stronger impact to society. You know, I mean, the beauty of IMEC, I think, is that we are really trying to combine the best of both worlds. We are we really have the possibility to really look far ahead, to really look at the fundamentals of the technology, to spend time on understanding all the materials and process aspects. But we do that in an environment that is run in a very professional way. That
Mm.
attracts a lot of people. I mean, in an environment that is run basically in an as professional way as in the industry. And that combination really attracts a lot of people. The fact that we have such strong relationships with universities also allows us to attract a lot of young people. Um,
Mm.
we have 850 PhD students that obtain a
Wow.
degree from one of the universities with whom we work, but they do their research project at IMED. In 850 people, young people that are started their career, that all are extremely passionate and want to basically have an impact, want to change the world with technology, that creates an enormous drive and motivation within the organization. And that keeps also the entire team extremely young and motivated. And that is creates a very unique culture, I think, that we have here at IMEC.
Just coming around to your passion, which is design and architecture.
Mhm.
Does it not fascinate you now that what you're building at a chip level, at a very sort of micro nano level, imitates
Mhm.
that architectural complexity of you know real buildings and things
Mhm.
and I don't know, cities?
Mhm.
Do you see
Yeah,
that similarity?
of course, there are similarities for sure. Designing a chip or designing a very complex environment, there are similarities. But I certainly, I'm very convinced that that passion certainly has influenced uh, the way I implement and the way I execute my job here. Just the feeling for design and the way how we kind of package messages. I mean, the way we communicate, the way we build presentations. I pay a lot of attention to that because I think it's really important for an organization like ours that we can get across a vision in the most convincing way. And so I believe that the way how you package this, how you make presentations is very important, and that's where my affinity for architecture and design certainly has
Yeah.
helped me.
Yeah.
But
Yeah.
also, even just very in a very practical way, I believe if you want to motivate people to come to work and to be very enthusiastic about what they're doing, if you create a work environment that is a nice place to be, that is very important. So I have also used my interest into architecture also to make sure that we build out our campus very nice way. I like to attract some of the top architects to design our buildings, and I'm personally very much involved into that aspect also, because the way we set up our buildings, what we're doing, a lot of the innovation starts from bringing multiple disciplines together, people with different backgrounds, people with
Mm,
coming from different departments. So we also have to design our workspace in a way that we maximize these spontaneous interactions between
yeah,
people.
yeah,
So the
yeah.
way we design the building, the way we design our office spaces is very important in stimulating innovation, and that's also one of kind of the sidetracks of my interest in architecture, which I think has contributed a little bit to that part.
Wow, that's good. The other thing I think I was just going to ask you was this pace of innovation over the last 40 years. I think it's almost. I mean, I wouldn't say exponential, but it's almost been exponential in the last like 5 years
Mm.
or
Nice.
What excites you right now about what's going on? I mean, there's so much going on. What is the big one or big thing that really sort of makes you think I'm so happy I'm in this industry?
Oh, I think that the opportunities are kind of endless. People have been talking about the end of Moore's law since so many decades, in fact.
Yeah,
And
yeah.
people have been predicting like this industry is becoming a mature industry and there will be far less innovation. But I think the opposite is true. I mean, if you now look at the drive, the drive by, for example, AI, and the needs for more compute power, I mean, it has never been as pronounced as it is today. So there
Mm,
is going to be this continuous drive to make more complex systems, more efficient systems, and so I think that that is what really fascinates me. That there is basically no end to this industry, the to the need for innovation in this industry, and I think there is great opportunities for the entire industry, for but also for organizations like ours.
it's sort of almost tempting to ask the question. So 40 years, what do you expect in the next 40 years? But it's actually so difficult now because you can't really say what's
Yeah.
going to be in the next 2 years. I guess.
No,
Well, you do. You have
exactly.
roadmaps, but still.
So we have roadmaps, and we see a possibility for continuing this Moore's law for the next 20 years. I mean, 40 years really is hard to predict. I mean, if you would have
Exactly.
asked me 40 years ago and started where we would be today, it would be completely different. I mean, just as an anecdote, when we started 40 years ago, um, it was, I mean, people were predicting the end of optical lithography at 1 micron. And I remember that when
Mm,
we designed our first clean room, that our lithography area allocated to e-beam machines was bigger than the optical lithography area. And of course, so it just illustrates that making predictions 40 years out is kind of nearly impossible.
yeah,
But I'm
exactly.
very sure that that in the next 20 years we're going to see this continued demand for more data, more AI, more compute power, and so and then all these new applications, like in healthcare, like in robotics, AI, VR, AR, VR. So
Mm.
I think the drive, the hunger for new technology is going to be endless. So that's going to keep on driving our industry. And yes, maybe we are in a more difficult time at this moment for many sectors in the industry, except for AI. But I'm very convinced that overall the industry is going to be very prosperous for the next decades.
Well, I tend to agree with you, but let's sort of bring this to a close. So, one of the questions I always ask my guests is, what would you, given your experience, what would you advise young Luke, knowing what you know now, when you're setting off in your career for your life?
Of course, that's always a very hard question, but I think if I look back, if I look at what helped us to get us where we are, I think is um, aim high, be ambitious, don't be shy of taking bold decisions. If you want to be an entrepreneur, you have to take risks. Of course, it has to be calculated risk, but aim high, be ambitious. But at the same time, although we have really obtained a leadership position in what we do, I think we have to stay humble. Stay humble because we are there. Because of course, success in the past is absolutely no guarantee for success in the future. And in the space where we operate, I mean, it's an ecosystem play. I mean, we are successful thanks to all the partners that trust us, and so we have to
Mm.
stay very humble, not become arrogant at all. Um, uh, and I think that's what is very important to kind of secure a bright future. Aim high, be ambitious, but stay humble.
Very, very good words. Well, Luc van der Hove, thank you very much.
You're very welcome. It was really a pleasure. Thank you.
Thank you.